Okay, hi everyone. My name's Michelle. I've come all the way from Australia. I'm from Macquarie University, Sydney. It's really far away from Krakow in Poland. Today I'd like to talk to you about X-ray fluorescence spectrometry and how we can use statistical analysis to determine provenance in ancient Egyptian faience. So, ancient Egyptian faience is a material that's found throughout Egypt's history. It's a glass-like material, mostly silicon, and it was coloured using metals. So if you've seen any blue scarab beetles or jewellery that's pretty in blue, that's faience. This hippo here, he's faience. So the blue is often coloured with copper, but you have reds and yellows and browns, all sorts of colours. It was mostly used for funerary items, so we see it in amulets that were buried or wrapped up in mummies, or jewellery as in necklaces on mummies, and shabdis, which are little workers that you make to take to the afterlife, because the ancient Egyptians were very clever and decided that they didn't want to work in the afterlife, so if they could make shabdis to do it for them, that'd be great. So there are hundreds of shabdis. We also only have limited information about how it was made and what it was made from. Unfortunately, that wasn't written down, but we, using kind of scientific analysis, we're starting to piece it together. So why would we study faience? It is everywhere. Like pottery in Egypt, faience is the same every excavation, every tomb, every mummy. There are hundreds of the stuff. So it's very easy to access. Every museum will have faience. I have never, ever had a problem asking museums if I can have a look at their faience collection, because they'll say, we've got thousands, what would you like to look at? It's a good alternative for destructive analysis. I'm not suggesting we should go out and destroy every piece of faience that we have. However, if you are allowed to do destructive analysis, because there is so much of it, you are more likely to be allowed, because there will be, there are hundreds of shabdis, you might be able to take one. And it was consistently manufactured throughout history. So just for those who are not Egyptologists, this is a very compressed timeline in ancient Egypt. Faience was made from the Predynastic period, all the way at the top, all the way down to the Roman period. So we've got, the pyramids built in the Old Kingdom, Tutankhamun's in the New Kingdom, we've got Jared Butler in, 300, he's in the late period, and Cleopatra's Ptolemaic. So we've got this really lovely database of development of material and technology and ceramics throughout Egypt's history. However, there is a problem there. I wouldn't be here if there wasn't one. A lot of faience pieces in Australia have no provenance. A lot of being in Australia, we're at the bottom of the world. We don't have access to all the wonderful collections that there are in Europe. So we tend to get the leftover pieces, the pieces that don't have provenance. So you can't quite see on these pictures, but the two on the left are from Melbourne and the two on the right are from Sydney museums, and basically all of them say, beautiful piece, no provenance, no age, no location. They're just pretty pieces. And without provenance or context, we really lose the historical information, and that does affect the economical value. So they're just nice to look at. And because they're glass-like, they're mostly silica, we can't use traditional dating methods. We can't do carbon dating or things like that. So we don't have a way to provenance faience, and we've got a lot of it that doesn't have a provenance. So my project is focused on determining a way to provenance faience. Because we have an abundance of samples, we can study the change in composition over time. Some of you might wonder why there's a phone on there. I like to think of it as an analogy as we can map the technology. So this is kind of like the first phone. We've got a spin thing, we have to pick it up and listen to it. But as we've, upgraded and we've developed and we've done all sorts of stuff like that, we've made lots of phones. So we went to buttons, then we made it mobile, then we made it really small, and the last version doesn't even really look like a phone anymore. It's just a computer, basically. So we can think of faience technology a bit like this, as technology increased, as trade routes developed, as we found new materials, as we could use new materials, the recipes and the manufacture changed. So based on this theory, we are taking the elemental composition of a huge database of faience. I currently have 266 faience pieces in Australia. They're all blue or green, because as we'll see in a minute, colour does really affect the elemental composition. And I have a mixture of provenanced and unprovenanced to try and start to sort out what's going on. To do the compositional analysis, I'm using something called X-ray fluorescence spectrometry. which determines the bulk composition of the artefacts. Now, if anyone's used XRF here, there are pros and cons. Pro is it's really quick and really easy. It's literally a point and shoot device. Within 90 seconds, I have data of an artefact. There are cons though. Because it's so quick and easy to use, it has limited results. I can't analyse light elements. I don't have information on the oxygen or carbon. I only have kind of the elemental. I don't have the molecules or the compounds. It's just perhaps this much copper-ish. And I say bulk analysis because the spot size is 25 microns. So bulk in the sense of a kind of a nano world is, wow, that's huge. But in the size of an artefact that big, it's not really bulk. So to combat that, we take multiple scan spots and average them to get an average bulk composition. So once we have our huge data set of elemental composition, we do some statistical analysis. So I've heard principal components analysis in a few talks, so some people might be familiar with it. For those who aren't, it's a multivariate analysis method that's really good at taking huge data sets and compressing it down to kind of just very simple axes. So what we do is we look for principal components. If there are any mathematical minds in here, we're doing the eigenvectors of the covariance matrix. So I take all of my samples, all of the elements, do the covariance of that, look for the eigenvectors, which best represent the variance. I'm looking for what trends best represent my data. And the first trend is my principal component number 1. My second trend is my principal component number 2. And so then from that, I can say, I take all of my data and I can shove it into, okay, well, how does everything rank compared to principal component 1 and principal component 2? And it's a really neat way of going, oh, what's the same or what's different? So just to quickly demonstrate how we can use PCA, I looked at different coloured faience beads, so something that would have been attached on a mummy, all different colours. So it was a single set as opposed to a large database of just random pieces. It was probably within one mummy. And what we can see is that, you know, the black looks like black and red looks like red, yellow looks like yellow. Blue and green samples look quite similar, and aqua is also quite similar. However, the aqua does look a little different from the blue and the green. And what that's reflecting is the presence of lead in the aqua samples that isn't really there in the blue or green samples. And so what we're seeing is decision making. We're seeing that the artisans went, well, aqua is different to blue. I'm going to put lead into my aqua samples, and therefore they might hold a slightly different significance. It might just be a pretty choice that they've made, but it's decision making. And that's kind of a cool thing to have a look into the ancient world. So here is my age and my provenancing. It is only 18 samples because I did finish a large database just before I got here and I didn't get a chance to chuck it into my PCA matrix. But 15 of the samples are from the Museum of Applied Arts and Sciences in Sydney. And they had rough age provenance. Some of them had very good provenance, like pieces that said definitely LP, late period, yes. Some of them did say New Kingdom to Ptolemaic, NK to PP, which is it's useless. The New Kingdom's here, the Ptolemaic period's here. It's like 1,000 years. It's not a date, not really. However, we do see that the late period artefacts do seem to cluster together in this positive PC2 and positive PC1. We also see some of the quite broad samples seem to cluster up there as well. So perhaps we can reevaluate their ages and say, well, you might say it's New Kingdom to Ptolemaic, but perhaps it's more late period, which is in the middle of those two time periods. I then chucked in 3 random samples from the Museum of Ancient Cultures at Macquarie University. They're from my beads from the previous slide. We came in a little box with a sticky note on them that said late period Egypt, which we can kind of throw that away. That's not really documentation. That's someone's wild guess. But it did seem to work. They seem to cluster very nicely with the late period faience artifacts. So maybe the sticky note was correct. We're adding weight to the arguments of how to provenance faience. So, future directions. I've just got blue boxes there because there are some human remains, and I'll reveal it at the end, but I just wanted to, just in case. So I did finish 180 scans just before I came here from the Nicholson Museum, which is at Sydney University. They have a wonderful collection that has both really well provenance samples from the Egypt Exploration Society, so we can kind of go, you know, they're probably okay. And 85 samples had location provenance. So I'm just going to unblock the boxes. What they do have is some hands, some mummified hands with faience rings. Now, they have no idea where these hands have come from, which I find really bizarre. We're from Australia, things just get sent to us. But they do have rings on them. So they haven't done, thank you, they haven't done any kind of carbon dating or anything, which is destructive. If we want to do carbon dating, we have to take a sample. It has to be a viable sample as well, which we don't know the history of these hands, so who knows. But perhaps if we can date the faience, we can date the hand. So that's what I will be doing when I get home. And they had a lot of hands. The next one is that before I came here, I got to do some work at the British Museum, which was super exciting. I got to analyse 39 faience samples there. They all had provenance because, of course, they did. It was the British Museum. And 34 of them had location provenance. Now, the exciting thing about why I went to the British Museum is that in Australia, a lot of our artefacts that do have provenance are all towards the later end of Egypt. We don't have any cool, really exciting feature pieces. So at the British Museum, they have these tiles here, which I find very exciting. They're from one of the earliest pyramid, Djoser's step pyramid. He had a whole selection of faience tiles. So this is kind of Old Kingdom faience. This is towards the start of our journey in this material. So I got the chance to analyse these, and hopefully perhaps some of our awesome pieces in Australia that have no provenance, maybe they will kind of sit similarly with Djoser's tiles. Kind of in conclusion, I'd like to really highlight the fact that we can take a sample such as faience. It's kind of regarded as low value. It's not glitzy, it's not glamorous, it's not the holy grail, it's just ceramic, it's a bit like pottery. But if we get these huge collections, which we all have, we have huge databases of coins, pottery, faience, ceramics, we can reinterpret the data and we can look at it differently by starting to look at the whole data set as opposed to perhaps just things from Cairo or just things from Thebes or whatever it happens to be. Thank you very much. That's all. Thank you very much.